Hello all, welcome to my lecture on problems based on EDTA titration for determining various types of hardness. Let us start with the basic principles that are involved in the problems. Let me start with the basic concept of hardness. What do you mean by the term hardness? When we are using a water with soap, if it lathers with soap, it is known as soft water. If it does not lather with soap, it is known as hard water. Such property is known as hardness of water. Is it okay? Then the next question arises. What is the reason or what are the reasons for hardness? When the water contains certain salts, say for example, magnesium carbonate or calcium carbonate, magnesium sulfate, magnesium chloride or calcium bicarbonate, magnesium bicarbonate. When certain salts are present in the water, they are interfering with lathering property. They are causing a scummy white precipitate. Instead of foaming, they cause a scummy white precipitate. This property is known as hardness of the water. Now, we can see there are various types of salts. In a salt, you will be having a positive ion and negative ion. Magnesium positive ion, carbonate negative ion. Magnesium positive ion, sulfate negative ion. Among these salts, when you are talking about carbonate and bicarbonate, such hardness can be easily removed by boiling. The hardness which are due to carbonate and bicarbonate, they can be easily removed by boiling. Such hardness is known as temporary hardness. They are known as temporary hardness. At the same time, if you are talking about sulfate and chloride, even if you are boiling the water, such hardness cannot be removed. They require certain special techniques like ion exchange method or zeolite method. The hardness which cannot be removed by simple boiling but requires some special techniques. They are known as permanent hardness. So, these are the two types of hardness. What is hardness? If the water doesn't lather with soap, it is known as hard water. Such property is known as hardness. The hardness may be due to various salts like magnesium ion, calcium ion, carbonate ion, chloride ion, sulfate ion. Out of the various combinations, if the hardness due to carbonate and bicarbonate, then they can be easily removed by simple boiling. Such hardness is known as temporary hardness. On the other hand, if it is because of the chloride and sulfate ions, they cannot be easily removed. It requires some special techniques known as permanent hardness. So, this is the overall idea about hardness. Then the next question arises, what is the standard for, what is the standard salt for hardness? We have a number of salts that are causing hardness, out of which we are mainly talking about calcium carbonate, CaCO3. Calcium carbonate is to be taken as the standard or reference for the hardness. Why is it so special? What makes the calcium carbonate as the special reference for hardness? Yeah, let me tell you. Calcium carbonate. What is the molecular weight of calcium carbonate? How can we calculate? For calcium, 40 atomic weight. Carbon, it is 12. Oxygen, it is 3 into 16, 48. So, 40 plus 12 plus 48, which altogether results in 100. Calcium carbonate molecular weight is 100. Always it is easy for us to use 100 in calculations. You just remember in our lower classes we used to have the tables. The 10th table and 5th table are always favorite to us because it is very easy to work out on the numbers of 5 and 10. The same trend happens here also. You can apply the same idea here. Calcium carbonate, the molecular weight is 100. Okay. What is the valency of calcium? Ca2+. Therefore, equivalent weight of calcium carbonate is 100 by 2, that is equal to 50. Yet another easy number when it comes to calculation. So, number 1, calcium carbonate molecular weight is 100. Calcium carbonate equivalent weight is 50. So, it is easy for us to use calcium carbonate as the standard in the calculation. What is the next important feature of calcium carbonate? It is not easily soluble in water, it will be easily precipitated. Any salt which is easily precipitated can be easily weighed also. It is easy for us to precipitate the calcium carbonate and weigh it. Because of these three reasons, calcium carbonate molecular weight is 100, equivalent weight is 50, it is insoluble in water, easily precipitatable. Because of these reasons, we are taking calcium carbonate as the standard for hardness. Is it okay? The last part, how do we determine the various types of hardness? What are the different types of hardness we discussed? Temporary hardness. What is the reason for temporary hardness? Because of the carbonate salt. So, the temporary hardness can also be known as carbonate hardness. In problems, we may be asked in terms of temporary hardness or carbonate hardness. We have to bear it in our mind, both are the one and the same. Temporary hardness is also carbonate hardness. In question, they may be asking to us to calculate what is the temporary hardness or calculate what is the carbonate hardness. Coming to the permanent hardness. What are the reasons for permanent hardness? They are the non-carbonate salt, may it be sulfate, may it be chloride, they are non-carbonate salt. So, it can be known as NCH, that is non-carbonate hardness. This is CH, this is NCH. What is CH? CH is the carbonate hardness. What is the another name of carbonate hardness? Temporary hardness. What is NCH? Non-carbonate hardness. It is also known as permanent hardness. When your CH and NCH are added, when you are adding up carbonate hardness and NCH. In other terms, when you are adding temporary hardness and permanent hardness, it will be giving you the total hardness. This is the important formula. CH plus NCH gives you TH. What is CH? Carbonate hardness or temporary hardness plus NCH, non-carbonate hardness. What is NCH? Non-carbonate or permanent hardness. When you are adding up these two, you will be getting the total hardness. Is it okay? So, with this basic background, we can further move on to the problems based on EDTA method. Now, we studied about what is hardness. Then we will go to some major aspects of EDTA and related reagents. Okay. Now, what is the title? Problems based on EDTA method. A further ideas on EDTA. EDTA stands for ethylene diamine tetraacetic acid. EDTA stands for ethylene diamine tetraacetic acid. We will be having the EDTA. It is a complexometric titration. What are the requirements? First of all, we should have a standard hard water. Standard hard water. Please recollect what we mentioned. What is the standard for hardness? Calcium carbonate salt. How will you prepare standard hard water? We have to take 1 gram of calcium carbonate salt. As it is insoluble in water, it has to be dissolved in some HCl. Then it has to be made up to 1 liter in an SMF. SMF stands for standard measuring flask. How will you prepare standard hard water? Standard hard water is prepared using the standard hardness salt. What is standard hardness salt? Calcium carbonate. When you are taking 1 gram of calcium carbonate and you dissolve it in HCl, after that it has to be made up to 1 liter in an SMF with distilled water. That is another requirement, standard hard water. It is used to standardize the unknown EDTA. Number 2, EDTA. EDTA solution. EDTA solution, we will be taking 4 grams of EDTA and then it will be dissolved. We will be preparing the EDTA solution. Then EDTA will be taken in the burette. The hard water will be taken in the pipette. To maintain the pH, to maintain any change in the pH, we are going to use one buffer solution. For this reaction, we are going to use ammonia buffer. And finally, we will be using, to indicate the color change, we are going to use Erichrome black tea indicator, EBT indicator. These are the 4 requirements for EDTA calculation: standard hard water, EDTA solution, ammonia buffer, and EBT indicator are the requirement. Now, let us consolidate the reaction procedure and principle in simple reaction. For example, consider I am taking one water sample, 100 ml of water sample. The water sample is hard water sample. Please remember, what is the reason for hardness? Calcium and magnesium ions present in the water. When calcium and magnesium ions present in the water, to that water we are adding ammonia buffer to maintain the pH around 9 to 10 pH. It will be available in water. It is going to react with your indicator. What is indicator? EBT indicator. The original color of Erichrome black tea indicator is steel blue. The steel blue EBT, it is the indicator. It is going to react with calcium and magnesium that is present in water. It will be forming an unstable complex, calcium, magnesium, EBT complex. This water is colorless. The color of your indicator is steel blue. When they are forming an unstable complex, instability is represented by the square bracket. It will be forming a steel blue unstable complex. This is called your steel blue complex. Right? Now, what is the second step? To the pipette solution, we are going to titrate it against the EDTA taken in the burette. Now, EDTA is slowly added to this pipette solution. What is the pipette solution now? It is a complex of calcium, magnesium, EBT complex. Now, what happens? This is unstable. EDTA is having a strong tendency to form a stable complex with this calcium, magnesium. It replaces EBT. When this EDTA replaces EBT, it will form calcium, magnesium, EDTA complex and EBT. The calcium, magnesium, EDTA complex is colorless. What is the original color of blue? EBT. It will be having blue color. Initially, it will be forming the calcium, magnesium, EBT complex will be wine red in color. The wine red complex will be converted into EBT blue. So, what is the end point? Wine red to steel blue. When you are having wine red to steel blue color change, that shows the end point is arrived. So, this is the overall idea about the principle. You are having calcium, magnesium ions in the water. It is added with EBT. It will be forming a wine red unstable complex. The wine red unstable complex is reacting with EDTA to form calcium magnesium colorless complex and EBT. The original color of EBT is blue. It will be regenerated. So, the end point is from wine red to steel blue. Is it okay? Now, let us move to the original idea behind the problems. We will start with problem 1. We will be doing a couple of problems. Yeah, we will start with a simple problem. The problem states that, let us say, 0.28 grams of the standard sample or standard hardness salt. What is the standard hardness salt? Calcium carbonate. 0.28 grams of calcium carbonate is dissolved in HCl and made up to 1 liter solution. 0.28 grams of calcium carbonate is dissolved in HCl and made up to 1 liter of solution using water, distilled water. Now, this is the sample. 100 ml of this solution, 100 ml of this standard solution requires 28 ml of EDTA. 100 ml of this standard solution requires 28 ml of EDTA. Is it fine? This is the first part. the problem is not yet over, the question continues. Then what happens? 100 ml of unknown water sample, hard water sample required 20 ml of the EDTA solution. Already the first statement is over. 0.28 grams of calcium carbonate is dissolved in HCl made up to 1 liter of solution using distilled water. 100 ml of this standard hard water requires 28 ml of EDTA. Till here we do not know what is the strength of EDTA. Only using this standard hard water we are going to determine the strength of EDTA in terms of calcium carbonate. What is the second statement? 100 ml of unknown hard water sample, that is given sample, that required 20 ml of this EDTA. That is the second question. We have to check the keyword unknown hard water sample. There is no mention of any boiling or heating, nothing is there. It is a simple unknown hard water sample. That means this is the total hardness. Then after boiling and filtering, the same sample is boiled nicely and then filtered. After boiling, 100 ml of the hard water required 10 ml of EDTA. 10 ml of EDTA. Now, they are asking us to calculate total, temporary and permanent hardness. So, this is the question. Very simple idea. This is the question based on problems based on EDTA method. I am repeating the question. 0.28 grams of calcium carbonate is taken. It is dissolved in HCl and using distilled water it is made up to 1 liter of solution. 100 ml of this standard solution requires 28 ml EDTA in a titration for neutralization. It goes without saying, when EDTA versus hard water, we may use ammonia buffer as the additional solution and EBT as the indicator. Okay. Now, we are going to the second part. 100 ml of the unknown hard water sample required 20 ml of this standardized EDTA. Using this data, we would have standardized what is the EDTA strength. That EDTA strength has to be represented here. 100 ml of unknown hard water sample required 20 ml of EDTA. What is the third statement? After boiling 100 ml of the hard water. Here without boiling we have taken the water as such, but here we have boiled it. After filtering 100 ml of the hard water required 10 ml of EDTA for the titration. The question asks us to find out what is the total, temporary, permanent hardness. Before proceeding with the answer, we have to analyze the question properly. What are the methods of analysis? Number 1. What are the requirements? We have to know that EDTA strength. The EDTA has to be converted in terms of calcium carbonate. Number 2. Out of the second and third statement, which represents total hardness, which represents permanent hardness. See, second statement, 100 ml of the unknown hard water sample required 20 ml of EDTA. We have not boiled. It contains both carbonate and non-carbonate. It contains both permanent and temporary hardness. So, the second statement calculation will give us total hardness. This is the clue. Right? Okay. And what is the third statement? After boiling. When you boil the sample, what kind of hardness will be removed? All the temporary will be removed. What else will be retained? Only the non-carbonate hardness will be. Non-carbonate also known as permanent hardness. The third statement gives us the permanent hardness. Okay. In question what they asked? Calculate the total hardness. Do we have clue for that? Do we have data for that? Obviously. What is that? the second statement. What is the permanent hardness? Is there any data that had been given to calculate permanent hardness? Yes. Where it is? The third statement. How about the temporary hardness? Is there any data given for temporary hardness? Analyze the question. No. Then what we have to do? Already we have a formula. What is total hardness? Total hardness is equal to temporary plus permanent. Am I right? Okay. Now they have given the total hardness, they have given the data for permanent hardness. Now using this formula, it is easy for us to calculate what is the temporary hardness. What is temporary hardness? Temporary is equal to total minus permanent. That's it. This is the way how we should proceed towards the problem. Then the next question arises. We would have arrived at the numerical value. It has to be represented with some units, right? Obviously, for any complexometry calculation or any calculation, if you are arriving at the answer, that is not sufficient. It has to be accompanied by the units properly. Here, can you guess what might be the unit? Yeah. What is the salt we have taken? Calcium carbonate. What is the weight? How can we represent the weight? It can be in grams or milligrams. Here we are taking it as the milligram. Milligram in how much amount of the water sample? In 1 liter of sample. So, milligram per liter. That is the unit we are going to arrive at. Whatever the answer we are having, we have to express in terms of milligram per liter. Or one more unit is also there. It is known as ppm. It is also very commonly used unit. ppm stands for parts per million. Parts per million. Technically speaking, both are equal. Milligram per liter and ppm are one and the same. Is it okay? With this idea, let us proceed into the actual problems. 0.28 grams of calcium carbonate. Yeah. Now, let us move on to the solution. Step 1. Step 1 is standardization of EDTA. Step 1, standardization of EDTA. What they have given in 1 liter, in 1 liter solution, it contains 0.28 grams of calcium carbonate. It contains 0.28 grams of calcium carbonate. How will you convert it into milligram? 280 milligrams of calcium carbonate. Am I right? 1 liter solution is equal to 280 milligrams of calcium carbonate. Now, 100 ml of this sample, 100 ml of solution. In 1 liter is 1000 ml. 1000 ml contains 280 mg of CaCO3. Therefore, 100 ml of solution will contain 28 milligrams of calcium carbonate. Am I right? For 1 liter, 280 milligram. For 100 ml, 28 milligram of calcium carbonate. Then what they have given, this 100 ml solution required how much amount of EDTA? 28 ml of EDTA. Let us do the reverse calculation. 28 ml of EDTA is equal to 28 milligrams of calcium carbonate. Is it logical? What we have given, 1 liter solution is equal to 0.28 grams of calcium carbonate, also 280 milligrams of calcium carbonate. But in the problem we have given, we have taken only the 100 ml of the standard solution. 100 ml solution is equal to 28 milligrams of calcium carbonate, that is requiring 28 ml of EDTA. Therefore, 28 ml of EDTA is equal to 28 mg of CaCO3. Where does it lead? 1 ml of EDTA. 1 ml of EDTA is equal to 28 by 28, 1. 1 mg CaCO3, calcium carbonate. This is called standardization of your EDTA solution. What is the standardization? This is the step 1. We have to standardize that EDTA. Standardization of EDTA arrives at 1 ml EDTA is equal to 1 mg calcium carbonate. This is the standard formula we are arriving at. That's it. Now we are going for step 2. What is step 2? Step 2 is the calculation of total hardness. Step 2 is the calculation of total hardness. Please recollect, total hardness is the combination of carbonate and non-carbonate hardness. Now we are going to calculate the total hardness right from the second statement. What is the second statement? 100 ml of sample hard water. 100 ml of sample hard water required 20 ml of that EDTA. What is the requirement? 100 ml of standard hard water is equal to 20 ml of EDTA. From standardization, we also know 1 ml EDTA is equal to 1 mg of CaCO3. Am I right? That is the equivalent formula. 1 ml EDTA is equal to 1 milligram calcium carbonate. You adopt the same technique to this first equation. 100 ml standard hard water is equal to 20 ml EDTA. That's equal to 20 into 1 mg of CaCO3. That's equal to 20 milligram of calcium carbonate. 100 ml standard hard water is equal to 20 milligram of calcium carbonate. But what is the expression of unit? Milligram per liter. We have to calculate the hardness for 1 liter. 100 ml standard sample hard water is equal to 20 mg calcium carbonate. Therefore, 1000 ml sample hard water is equal to what? What is the answer? For 100, 20, for 1000 watt. By simplifying, you will be getting 200 milligram per liter. What is 200 milligram per liter? That is called total hardness. Okay, a part of the answer is arrived. Total hardness is equal to 200 milligram per liter. Right? Okay. Then we will be going to the step 3. Step 2 is over. What is step 3? Step 3 is the calculation of permanent hardness. We will be going to step 3. What is step 3? Finding out permanent hardness. Why do we call it as permanent hardness? Because the sample is boiled now. All the temporary hardness had been removed. The remaining one is only the permanent hardness. Correct? Now, what is the step again? Already we have 1 ml EDTA is equal to 1 mg CaCO3 we have. It's very clear. Now, what is the statement that had been given in the problem? 100 ml of boiled hard water required 10 ml of EDTA. 100 ml of boiled hard water required 10 ml EDTA. By the equivalence, we can say 10 ml EDTA is equal to 10 mg of CaCO3, calcium carbonate. Again, the question arises, what is the unit we have to express in terms of milligram per liter? Liter, that is the clue word. So, 100 ml, we got 10 mg of calcium carbonate. We have to find out for 1000 ml of boiled hard water is equal to how much? What is the answer? For 100 ml, 10 mg of calcium carbonate. Therefore, for 1000, we have to calculate. What is the answer? By simplifying, we are getting 100 milligram per liter. What is 100 milligram per liter? It is your permanent hardness. Permanent hardness is equal to 100 milligram per liter. First step, we started with the standardization where we arrive at 1 ml of EDTA is equal to 1 mg of calcium carbonate. First step is over. Second step, what is the total hardness? Total hardness we arrived at 200 milligram per liter. What is the third step? Permanent hardness. Permanent hardness, what is the solution did we get? Permanent hardness is equal to 100 milligram per liter. You recollect what is the question? In question they have asked about what is the total hardness, what is temporary hardness, what is permanent hardness. We arrived at total and permanent. What else is left behind? Temporary. Already we discussed about what is temporary hardness. For that, what is the formula? Yeah, total hardness is equal to temporary and permanent hardness. So what they are asking now? What is the temporary hardness? Temporary hardness is equal to total minus permanent. What is temporary hardness? What is the total? 200 ppm. What is permanent hardness? 100 ppm. So what is the answer? 100 ppm. So this is the concept. In examination, after completing the entire problem, after solving the entire problem, we have to take each and every answer and we have to consolidate the answer. Then you have to write solution. Number 1, total hardness is equal to 200 ppm. Permanent hardness, number 2, permanent hardness is equal to 100 ppm. What's the last thing? Temporary hardness is equal to 100 ppm. By adopting such methodology and practice, we can get full marks on this problem. This is the basic model and it's a sample we have taken to explain the steps involved in this. In examination, it won't take more than 10 minutes to solve the problem. It is an easy problem. For our better practice, let us discuss one more problem and then we'll have a better grip on this problem. Okay, let us go to the problem number 2. Sometimes what happen, instead of giving the standardization, they will be simply giving you, assume you are having a standard EDTA. Standard EDTA means there is a standard formula, 1 ml, 0.01 m EDTA is equal to 1 mg calcium carbonate. It goes without saying, it is a standard formula. Let us discuss a problem where the standardization is not required. That is the problem number 2. Now we will go. Okay. Let us discuss another one simple problem. Problem number 2. Problem number 2, let us take in a hardness determination EDTA complexometric titration, 50 ml of sample hard water required 18 ml of 0.01 m EDTA. This is the first statement. They have given the standard value or strength of your EDTA solution. There is no need for us to standardize EDTA. They are directly starting with 50 ml of sample hard water required 18 ml of 0.01 m EDTA. The same water sample after boiling, the same water sample after boiling and filtering required 12 ml of the same 0.01 m EDTA. This is the second statement. What is the second statement? The same water sample after boiling, that is the catchword, after boiling required 12 ml of same 0.01 m EDTA. Calculate TH, CH, NCH in ppm. The question is calculate TH. What is TH? Total hardness. What is CH? Carbonate hardness. What is NCH? Non-carbonate hardness. The unit also they have mentioned, ppm. Already we know ppm is the exact equivalent to milligram per liter. So here also we are going to adopt the same methodology. Here already they have given what is the strength of EDTA. What is the standard formula? We have to have the standard formula. Standard formula 1 ml of 0.01 m EDTA is equal to 1 mg of calcium carbonate. That's it. There is no need for us to standardize. Already they have given the standard of EDTA, ethylene diamine tetraacetic acid. Standard formula 1 ml 0.01 m EDTA is equal to 1 mg of calcium carbonate. Now we will go to the step 1. What is the step 1? To find out TH. What is TH? Total hardness. Fine. What is the statement they have given? 50 ml sample hard water required 18 ml of 0.01 m EDTA. Am I right? That's what they have given in the problem. 50 ml of standard hard water is equal to 18 ml of 0.01 m EDTA. Already we have the standard formula. What is the standard formula? 1 ml of 0.01 m EDTA is equal to 1 mg of calcium carbonate. So it can be easily substituted as 18 milligram of calcium carbonate. How much? 15 ml of standard hard water, sample hard water. 15 ml of sample hard water required 18 milligrams of calcium carbonate. Then we have to find out the hardness in terms of ppm. ppm stands for parts per million or milligram per liter. We have to find out for, instead of 50, we have to find out for 1000 ml. Therefore, 1000 ml of sample hard water is equal to, how will you calculate? Simple cross multiplication. For 50 ml, 18 mg. Therefore, what you have to find out for 1000 ml? Am I right? What is the answer? The answer will be 360 ppm. What is 360? The total hardness is 360. The total hardness is 360. In a jiffy we have arrived. Very easily we calculated the total hardness. Further, what is the next step? Carbonate hardness. For carbonate hardness, no data had been given. Then we have to utilize the data that is given for non-carbonate hardness. That is your step 2. What is non-carbonate hardness? When you are boiling the water, all the carbonate hardness will be getting evaporated as the carbon dioxide. Only the non-carbonate hardness will be left behind. Therefore, non-carbonate hardness, it is also known as permanent hardness. Permanent hardness. Good. Now, what is the data they have given? 50 ml of boiled hard water. 50 ml of boiled hard water will be equal to how much of consumption of your EDTA? 12 ml of 0.01 m EDTA. Correct? 50 ml of boiled hard water is equal to 12 ml 0.01 m EDTA. What's my next question? How will you convert this equivalent into in terms of calcium carbonate? 50 ml of boiled hard water is equal to 12 mg of calcium carbonate. Am I right? It is very logical. 50 ml of boiled hard water is equal to 12 mg of calcium carbonate. It is not sufficient. Again, what is the unit? ppm or milligram per liter. That means I have to calculate the milligram equivalents for 1 liter of the sample. 1 liter is equal to 1000 ml. Therefore, 1000 ml of boiled hot water is equal to how much calcium carbonate equivalent? Simple formula, for 50 I am having 12 mg. For 1000 how much will I get? Answer is 240 ppm. What is 240? My NCH, non-carbonate hardness, is equal to 240 ppm. What is total hardness? 360. Now you may understand where does it lead. What is the last step? Step 3. Step 3. What is step 3? Step 3 is your carbonate hardness. Carbonate hardness is equal to total hardness minus non-carbonate hardness. Carbonate hardness is equal to total hardness minus non-carbonate hardness. What is total hardness? 360 ppm. What is non-carbonate hardness? 240 ppm. What is the final answer? Carbonate hardness is equal to 120 ppm. Hope you remember what we have given the instruction regarding examination point of view. You have to consolidate the answer once again. You have to write all the 3 answers once again in the solution part. How will you write that? You have to write till this part. Solution. Point number 1. Total hardness. How much did we calculate? 360 ppm. What is the second part did we discuss? Non-carbonate hardness. We can also write permanent hardness, but in question they have asked about NCH. So let us use the same terminology. It's not wrong even if you are writing as the total hardness, but please see what it is given in the question. In question they are asking about the carbonate hardness or non-carbonate hardness. So non-carbonate hardness, what was the answer? It was 240 ppm. And what is the last step did we discuss about? That is known as your carbonate hardness. As I said already, carbonate hardness also okay or temporary hardness is also okay. But in this particular case, in this question, they are asking about the carbonate hardness. So let us practice the same terminology. Carbonate hardness, that's equal to, what is the answer? 120 ppm. When you are consolidating all the answers, that will be giving a good impression, and the answers will be very neat and clear. Hope we have a clear idea about how to proceed with the problems that are based on estimation or calculation of various types of hardness using EDTA titration method. Thank you one and all. See you in another lecture. Thank you.